So good morning, everyone. We'll continue our lesson, horizontal alignment, which is about the sight distance for horizontal curves. So it is the sight across the inside of the curve. So this is very important, especially when traveling along the curves. So where there are sight obstructions on the inside of curves or in the inside of median lane on divided highways, a design may need adjustment in the normal highway or change in the alignment. So if there is problem in the sight distance, we need to adjust so that again sa definition sa atong highway engineering, it should be safe. So we must foresee these things on our design. So with the sight distance as speed control, the designer should check the actual conditions on each curve and make appropriate adjustments to provide adequate sight distance. Where sufficient stopping sight distance is not available because a railing or a longitudinal barrier or whatsoever structure that causes a sight obstruction, alternative designs should be considered for both safety and economic reasons. We must increase the offset of the obstruction. Ipalayo nato siya sa ato ang road para na ay clear nga pananawa ng atong driver, or ang atong i-increase nato ang radius sa atong curve, mautro ang iyang alignment, or we will reduce the design speed. So how to solve for the sight distance for horizontal curves? So let's say this is the curve of your highway, curve section of your highway. This is the highway center line. So the middle of that, of your lane, is where we will measure our sight distance, our stopping sight distance. So its distance from the chord or the horizontal line of sight is called HSO, or the horizontal sight line offset. So how do we solve for this horizontal sight line offset? So the formula is equal to R times 1 minus cosine 28.65 S over R. So it looks familiar ba? So actually that comes from the formula of our middle ordinate. So ang atong middle ordinate, if you remember, the formula for our middle ordinate is M equal to R times 1 minus cosine I over 2. Pero iyahan ang simplify in which, wait ha. So that is M equal to R times 1 minus cosine I over 2, in which si I iyahan nang convert from LC. Kani si S muna ang atong length of curve. Ang iyang stopping sight distance. Muna ang length of curve sa atong previous nga formula. So that is, gikan na siya diri, LC over I, kada atong ratio and proportion, 2 pi R over 360. So solving for I, that is equal to 360 times the length of curve over 2 pi R. So substitute nimo ni si I diri ma-obtain nimo 28.65 LC over R, in which horizontal sight line offset ang nakabutang lang diri nga denote, a symbol nga atong gi-denote for the length of curve is S, or the stopping sight distance. Okay? So that is the formula that we will use. So same concept earlier or sa atong mga previous nga lessons para dili mo maglisod og memorize sa atong formula. Just remember nga ang sight distance nato is always in the middle of our lane. This is the outer edge and the inside edge of the lane. Okay, so what if diretso na to earlier kanya tong formula, no? Same lang na sila, 90 over pi, 28.65 over r. Sorry, lahi lang ang na-denote, wala na edit ang symbol. But what if ipagagawas na to si SSD? That would be pi r over 90 times cosine to the negative 1 r minus HSO over r. Okay? Sige, let's have a sample problem. A large grain elevator is located 40 feet from the center line of a two-lane highway, which has 12 feet width per lane. The elevator is situated on the inside of a 12 degrees horizontal curve. Assuming that the elevator is the only sight restriction on the curve, what is the minimum sight distance along the curve? B, what should be the maximum design speed recommended for this curve? And if the designer wants to have the design speed of 10 mph higher than the recommended speed, what is the distance required for the movement of the elevator? Okay, so what are our givens? So ang atong curve sa highway has a central angle of 12 degrees. And a large grain elevator is located 40 feet from the center line of a two-lane highway. So possibly two-lane highway, one direction, one lane per one direction. So 40 feet siya kalayo. So possibly muni ang atong HSO nga value. And ang width kada lane is 12 feet. Okay? So let's solve. That's the first, assuming let's solve for the sight distance. Okay. So 40 feet from the center line. So 40 feet from the center line, let's consider one lane. So center line meaning tunga sa atong duha ka lanes. So 40 feet from the center line. And then again, si horizontal sight line nato, sight distance nato is sa center line sa usa ka lane. Okay? Then HSO, this is the HSO. Dira ta mag-measure gikan sa center line padaron dira. Okay. Let's solve. So let's first do solve for our radius. So that is 100 over d equal to 2 pi r over 360, ratio and proportion. So that is solving for our 360. Sorry. Our 12 degrees pala is the degree of curvature, not the central angle. So that is 12, 2 pi r over 360, 5,729.578 over 12 equal to 477.465 feet ang atong radius. Then solving for our stopping sight distance using this formula or katong formula natin earlier. Substituting R and substituting the given HSO, which is so ang HSO nato actually is from the center man no, so total width sa atong lane is 12 feet. HSO is from here to here. So that is total kaninga length 40 minus sin ani dire 40 minus 6. So muna siya ang mabilin sa atong HSO. Muna ang length sa atong HSO. So malito ako na-mention kaganina. So that is the length of our HSO. So solving for the stopping sight distance, we have 362.522 feet. Okay? So that is the required stopping sight distance due to the obstruction in the vision. Next, what should be the maximum design speed recommended for this curve? So what formula we will use to determine the speed for this curve? So again, since it's talking about sight distance, we will use the formulas we've discussed in our sight distance topic. So, again, same formula lang si passing sight distance and si stopping sight distance o si decision sight distance. So, kato silang atong gamiton. Kaya dili man po ni passing, kaya dili man siyang overtake. It's just that na lang siya should have a clear distance para whatsoever nga naa sa tunga maka-decide siya sa iyang buhatan dayon. So we will use the stopping sight distance. So if you recall our formula, that is 1.47 VT plus 1.075 V squared over A if English system. So kaning 1.47, again, conversion factor ni siya kay dapat ang atong unit gamiton diri sa V should be MPH. And ang atong A is feet per second squared. And wala man given, so gamiton na to ang standard nga ginagamit, which is 11.2 feet per second squared. And ang atong T nga 2.5 seconds. So again, if mag-listen mo, remember sa formula, dito lang mo sa pinaka-concept and then conversion factors lang ning 1.47 o si 1.075. Try to solve it on your own nga nung abot ana nga formula. Dili na ako i-discuss diri. So substitute na to. 22.522 equal to 1.47 V. Muna atong ginapangita ang atong design speed. 2.5 seconds plus 1.075 V squared over 11.2. Solving for V, you will get 45.226 mph. So that is the design speed on this curve due to the obstruction. Next, if the designer wants to have the design speed of 10 mph higher than the recommended speed, what is the distance required for the movement of the elevator? So, what if patasan nato ang atong design speed? So, mag-adjust na po ang atong stopping sight distance. So, how do we do it? So, Again, add na to ang atong speed og 10. May mo na siyang 55.226 mph. Then from there, let's solve for our stopping sight distance. Using the formula we used earlier, SSD 1.47 VT plus 1.075 V squared over A. Substituting our speed and the standard time and acceleration rate. So our SST would be, or our stopping sight distance is 495.693 feet. Now, pila may i-move nato sa atong obstruction. So from there, SST, again, gamito na itong formula for that middle ordinate ng formula. Substitute na to itong SSD. Ganyan na ito ng formula. Again, simplified lang ni. If you don't recall it, understand the concept or recall the concept. So substitute our R, which we obtained earlier, na 477.465, 1 times 1 minus cosine 28.65 times our 495.693 over our R na 477.465. So you'll be able to get nga HSO na 62.905 feet. Is this our final answer? No. Kaya pangutan na niya, distance nga, i-move din mo ang elevator sa iyang original nga location. So HSO pa man na nga measurement, so ato siyang i-minus sa atong na solve earlier nga HSO. So that is 62.905 minus 34. We need to move our elevator at 28.905 feet so that we can increase the speed along this section. Okay? So I hope you are able to follow. If you have questions, then just message me in our group chat. So that would be all for our side distance for horizontal curves. So for spiral curve transitions, so a vehicle follows a transition path as it enters or leaves a horizontal curve. The combination of high speed and sharp curvature can result in lateral shifts and imposition and encroachment of adjoining lanes. Tungod kay again maiwit usually na ang likod nga mga ligid. So advantages of spiral: provides natural, easy to follow path for driver, less encroachment, promotes more uniform speed, lateral force increases and decreases gradually, simulating natural driving. Then provide location for super elevation runoff, which we will discuss in the next topic. Provides transition in width when horizontal curve is widened. And aesthetics, avoids noticeable kinks and breaks in pavement due to the curve. So the minimum length of spirals, this is the formula that is used. So this is from the AASHTO guidelines. Length of spiral minimum is 0.0214 V cube over RC. Pag metric, pag English, it's 3.15. Where R is the radius of the circular curve, V is the design speed, and C is the maximum rate of change in lateral acceleration, which is the standard is 1.2 meter per second squared or 4 feet per second cube. And also use this formula equal to square root of 24 P mean times R, where P mean is the minimum lateral offset between the tangent and the circular curve. For the maximum, that is 24, square root of 24 P max times R. So more practical, assume L equal to the length of the super elevation runoff. Okay, so to further discuss the maximum length of spirals or the spiral transition curves, I will let you watch the video. Uh, just see, just look for the link. Okay, so that would be all. Please study. This will be included in our quiz next week. Thank you so much.